Test scores are normally distributed with a mean of 78 and a standard deviation of 10. Find the test score that separates the bottom 70% from the top 30%. We're going to start by drawing a picture of our normal distribution. And in the middle, we're always going to put our mean, which in this case is 78. We are told that the standard deviation is 10, and we want to find the test score separating the bottom 70 from the top 30. Well, the bottom 70%, if at 78 we're halfway, 70% is going to be farther to the right. I'm going to say this makes this side about 0.70 and this side about 0.30. And we want to find what is that x value. We're going to have to go to our standard normal probability table, and we're going to have to find 0.7. We find 0.7 because the standard normal probability table gives us area under the curve to the left of our z value. We wouldn't find 0.3 because that is the area to the right. I'm going to go to my table, and I know to go to the positive side of my table because I'm above my mean. Positive z values are above the mean. So I look for 0.70 in the body of my table. I want to find the value that is closest to it. It looks like we're between 0.6985 and 0.7019. The one that is closest to 0.70 is 0.6985. We find the z value. It's 0.52. Our z is 0.52. Now we just have to use our z formula and substitute in what we know. Z equals x minus our mean divided by our standard deviation. Here our z is 0.52. We're trying to find x. Our population mean is 78 and our population standard deviation is 10. I'm going to multiply both sides by 10. And I have 5.2 is equal to x minus 78. Then I'm going to add 78 to both sides. We find out that x is equal to 83.2. Therefore, the score that separates the lower 70% from the upper 30% is a score of 83.2.